Hello, welcome to yet another episode where we'll be looking at the revision test for the grade 11s mathematics, the September test, okay? So it's this time of the year when we prepare for the end of term test. And with this paper, or even the papers that you'll be writing, there are topics that we can expect. Number one is the finance, okay? Number two, we have probability. And then number three, we have the statistics. Okay, so basically these three topics is what we can expect. Other examiners could also add what we call the algebra, just for practice purposes and just to make the paper a little bit count more. Okay, so let's dive into the questions. They're telling us that we have 4 questions. We need to answer all of them and appropriate correct numbering system. Clearly show all the calculations and then a scientific calculator. 2 decimal places is the rounding off unless we are told otherwise. Diagrams are not necessarily to scale. Okay, question number 1. It's telling us that Tabang and Tabiso invest 7,000 each for 5 years at 10% per annum at the same financial institution. Determine whose money will accumulate more interest if Tabang's investment earns simple interest and Tabiso's earns compound interest. So in this case, they are basically testing us whether we know the formulas for simple interest as well as the compound interest. So what I'm going to do, let me just use this other page, okay, and start with Tabang that uses simple interest. We know that simple interest is A equal to P into 1 plus IN, whereby our A is the accumulated value, P is the initial amount or the principal amount, I is the interest rate, and then that is the period of time. So we know that our P is 7,000. Okay, that's 1 plus. The interest rate, they told us it's 10%. So 10 over 100 times the same number of years, which is 5 years. Okay. Then when we punch that into our calculator, 7,000 into 1 plus 10 times, okay, it's 10 over 100 times 5, we're getting 10,500, okay? Then we go to Tabiso. We look at Tabiso, which is the compound interest. And that compound interest is P, 1 plus I to the exponent of N. It's a 7,000 into 1 plus is 10 over 100 to the exponent of 5. Okay, when you substitute that into the calculator, 1 plus 10 over 100 to the exponent of 5, we are getting 11,273,57. Now, given the fact that the final amounts or the accumulated values, they're different, okay? So this amount is higher than this one, meaning that Tabiso or Tabiso's investment will earn more interest, earns more interest. So that is our 1.1. All right, then 1.2. The following items were bought on hire purchase agreement at a furniture store. Okay, so all of this. The account must be settled in 30 months, a 15% deposit required, and interest will be charged at 18.5%. You have to pay insurance of 30 Rand per month, calculate the value of the loan. So for us to get the value of the loan, let's start by getting the total of all the items. So if we have 2750 plus 6.5 plus 1.8, that gives me 2750, 6.5, and then 18. So 11,050. Okay, so this is the cash price. Now, if you pay 15%, meaning that 85% will be the loan. So 85 over 100 times 11,050. Okay, so this answer, we're multiplying it by 85%, meaning that you're going to borrow 9,392 and 50 cents. Okay, so this is what must be borrowed. Then calculate the monthly payment. So with this amount that is borrowed, it is going to attract interest at the rate of 18.5 for a period of 30 months. So we shall come down and say that the 9392.50, this is going to be our p-value. The interest rate is 18.5%. Our period is 30 months over 12. I don't know, 30 over 12 is going to be like 2.5 years. Now, whenever you're dealing with hire purchase, the type of interest that is used is what we call simple interest, okay? So write down the formula of simple interest, 1 plus IN. So that's 9392.5 into 1 plus. The I is 18.5 over 100 multiplied by the 2.5. Okay, when I punch this into my calculator, we're saying 1 plus 18.5 over 100. We're saying times 2.5. That gives me 13736.53. Okay, so this is the total amount that must be paid back. Let's divide this by 30 to get how much we're going to pay per month. So divide by 30, this becomes 457.88 rands. All right, so that is how we would have answered that for the 3 marks. And then question 2, events A and B are such that probability of A is that, probability of B is this, and probability of A and B is this. Can we calculate the probability of A or B? So 2.1, they're asking us for the probability of A or B. From our addition rule, it's probability of A plus the probability of B minus the probability of A and B. So our A is a 0.6 plus 0.5 minus the N is 0.3. Okay, so 1.1 minus a 0.3, which becomes a 0.8. Okay, so that is what we would end up with. Then question 2.2. The table below shows 120 grade 11 learners classified according to subject choice and gender. For mates, we have 25 males. Mates split, we have 30 males, a total of 55 males. For mates, we have 40 females. We don't know the females that are doing mates split, but we have a total of 65 and so on and so forth. Calculate the value of A. So this A can be obtained either using the row or the column. Either way, we have the total of 55, 65, so we can subtract 65 minus 40, it's going to be a 25. 55 minus 30 is still a 25. So I'll say 55 minus 30 comes a 25. Then if a learner is randomly selected, what is the probability that the learner is male? So how many male learners do we have regardless of whether they're doing maths or maths lit? So we have 55, okay? So it's going to be 55 divided by this total here, the 120. Feel free to simplify that. So 55 over 120 gives me 11 over 24. Or you can give it as a decimal. Then a female that chose maths, it's 40 over 120, which becomes 1 over 3. A male that chose maths lit, a male with maths lit is 30 over 120, which is 1 over 4. And then a male all chose maths. Let's put it aside. A probability of male or chose maths. That's going to be probability of male plus the probability of maths minus the probability of male and maths. Okay, so how many males do we have? We have 55 males. So that's going to be 55 over 120. How many chose maths? It's 65. So that's 65 over 120 minus how many males chose maths, which is 25. Okay, so 25 over 120. Okay, so 55 plus 65 minus 25, which becomes a 95. over 120. Simplify that. That gives us a 0.79, or you can have a 19 over 24. Okay, either way. That's what the question wanted. Then determine whether or not events being male and doing med-slit are independent. Okay, so male and doing med-slit independent. So we're gonna say that the probability of being male and doing med-slit should be the same as the probability of being male times the probability of doing med-slit. So this is the formula for independency. So how many males are doing med-slit? We have 30 of them. So meaning that we're going to have 30 over 120. How many males do we have? We said it's 55 regardless. So 55 over 120. How many are doing med-slit? It's also 55. Okay, so 55 over 120. So this becomes 1 over 4 is equal to, that's 55 over 120 times 55 over 120, which gives me 121 over 576. So times it's a good habit to change this to decimals and see. We are getting 0.21. Now we're seeing that the left-hand side is not the same as the right-hand side. So in this case, we can say that events are not independent. Events are not independent. So that is how we would have answered that part. Then question number 3. In a box of colored sweets, we have 6 white and 9 pink. The sweet is taken out and eaten. Another sweet is taken out and it's also eaten. Draw a tree diagram. Now, when you take out sweets and you eat them, it's like picking without a replacement. So 6 white, 9 pink. Okay, how is the tree diagram gonna look like? So 1, we can have a white or we can have a pink. If the first sweet to be eaten was a white, the second one can be a white or it can be a pink. If the first one was a pink, the second one can be a white or it can be a pink. Then let's indicate the probabilities. So it's gonna be 6 over 15, 9 over 15. If you take out a white first, which means the number of the whites in the second turn is gonna reduce to something like 5 over 14. The pinks will still be the same. If the first one was a pink, the number of the pinks will reduce to 8 over 14, and then the whites will stay the same. So remember, so for every branch that we get, we must always get a total of 1. All right, let's see. Okay, so our outcomes will be white and white, white and pink, pink and white, pink and pink. So those are the outcomes, and this would be our tree diagram. Okay, then 3.1.2, determine the probability of having 2 sweets. Okay, so we're looking at P and P, meaning that the first P is a 9 over 15 times the second P will be 18 over 14. So whenever we are looking at multiple events, we just multiply the probabilities. Okay, so what that is going to be is like a 9 over 15 times 18 over 14. And that becomes a 27 over 35. Or you can give it as a decimal as a 0.77. All right, then part B, 2 sweets of different colors. Okay, meaning that we can have the white and pink, probability of white and pink, and also probability of pink first and then white next. Okay, so white and pink is going to be 6 over 15 times the 9 over 14. Then plus the white, and then, no, it's the pink first and then the white. It's going to be 9 over 15 times 6 over 14. So it's the same thing, but multiplied twice. So what we are saying is that 6 over 15 times 9 over 14 saying times 2. That gives me 18 over 35, which is 0.51. All right, so that is how we would have gone about with that question. 3.2, they're telling us that all grade 8s had to complete a questionnaire regarding their participation in the following sports code. We have athletics, netball, and then the softball. The following information was collected from the questionnaire. So we have like 3 events. Let me try to squeeze it somewhere here and see if it will fit. Okay. All right. Perfect. So athletics, netball, that's a softball. Okay, then they are telling us that 4 girls take part in athletics and netball, but not softball. So the 4 can be found there. Then 7 girls take part in athletics and softball, but not netball. So 7 is going to be here. And then 10 girls take part in the netball and the softball, but not in athletics. So 10 must be there. 24 girls take part in the netball, but not in the softball and not only. So this is just netball only, which is going to be somewhere there. Then 40 girls take part in athletics. The total is 40. 53 softball, and then 56 will be for netball. Then 8 girls do not take part. It has to be outside there. Then draw a Venn diagram for the data. So if I let my players that are taking all the 3 be X, I need to fill up these parts. Okay, so this is 7 and 4, that's 11. Okay, it's like X plus 11 should be 40. Okay, I'm looking for what is left here, meaning that's going to be 40 minus 11, which is a 29, minus X. So 29 minus X. And then this is 17. So 53 minus 17 is going to be a 36 minus X. I think that's the Venn diagram that they needed for the 5 marks. Then 3.2.2, how many of the grade 8 learners take part in all the 3? Now you can do the plussing of everything and then equate it to the total number, but do we know the total number? We don't. So the easier way is just to use this set of the netball, okay? Meaning that if we get our X plus 4 plus 10 plus 24 must give us a 56. Does that make sense? There's something that I'm not agreeing with here because they told us 56 girls play softball. No, 53. So 53 minus 17 is 36. Yeah, let's leave it. Okay, plus everything equal to 56 just for the netball. Then we know that this is a 34, that's gonna be a 38. So 56 minus 38, that gives me a 21. Okay, meaning that X is gonna be a 21. Okay, that is what I'm ending up with. You can correct me if I've gone astray, because that's a 34, 38. Okay, 56 minus 38, we get, no man, it's not a 21. We're getting 18. What's my calculator saying? 34, 38, 56 minus 38, we're getting 18. Okay, so we have 18 girls that are taking part in all the 3 sports. Then 3.2.3, if one girl from the grade 8 is chosen at random, what's the probability that the girl participates in all the 3? So it's going to be 18 over the total number. And what is that total number? So let's see if we have to find the total number. So what is 29 minus 18? That's going to be 11. We have the 18 there. 36 minus 18 is going to be 18. And then we plus up everything within the sets. So 11 plus 18 plus 24. Now I'm looking at the intersections now. We are saying 7 plus 10 plus 4, and then plus the 18 in the middle. That's 92. And then when I plus the 8, that's going to be 100. Okay, so 18 over 100, which is 0.18. All right. Then question number 4, we have the following table gives the weights of different rugby players from around the world. Okay. And then the first question, they want us to complete the cumulative frequency. So with the cumulative frequency, the first frequency must be the same as the first cumulative. And then we go on adding. 4 plus 6 is a 10. 10 plus 6 is 16. 16 plus 7 is going to be a 23. Plus 8 is 31. And then plus 11 is a 42. Plus 9 is going to be a 51. Plus 6 is a 57. Plus 2 gives us a 59. Okay, so that is that. And they want us to draw the ogive. Now, when you're drawing the ogive, we're going to look at the upper class intervals. Okay, the upper classes together with the cumulative. Now, let's try to sketch this. I think I can put it somewhere here. I don't know why I'm drawing this line, but okay, so if this is my 80, does it start from 80 or 85? Starts from 85, so meaning that I can also start from 85. Okay, it's not a big deal. So that is 85, that's gonna be, that's 85 up to 90. And then we have 95. And then we have 100, 105, 110, 115, 120, 125. It goes up until 130. So I can put the 130 somewhere there. And then along the cumulative frequency, okay, this is going to be our cumulative frequency. We can have intervals of highest is a 59. So 1, 2, 3. So it's 1, 2, 3, 4. So let's have this. 1, 2, 3, 4. 1, 2, 3, 4. It's this one. 1, 2, 3, 4. 1, 2, 3, 4. Okay, then 1, 2, 3, 4, 5. How many do we have? 1, 2, 3, 4, 5, 6. So I have 6. 6, I can use 10, 10. Okay, this is a 10. This is a 20, a 30, a 40, a 50, and maybe a 60. Okay, so the first interval, we said it's a 4. Okay, 4, 10, 16, 4, 10, 16, and 23. Okay, so 4 is going to be somewhere here. 10, then 16, that's 10, 12, 14, 16. And then we have 23, that's 22. 23 is going to be somewhere there. Okay, then from the 23, we have 31, 42, 51. 31, 42, 51. So 31 is going to be there. And then 42 is going to be there. 51 should be slightly above 50. Okay, then from the 51, we have 57 and 59. Okay, so 57, this is 50, 52, 54, 56, 57, and then 59, which is just going to be somewhere there. And then you have the right to connect this with your free hand. on the pencil. Okay, something like that. Then you have to foot this graph. In other words, you must start from the starting interval, which is that. Okay, so that becomes our cumulative graph. Then 4.3, they want us to use the algebra to determine the Q1, Q2, and Q3. Now, when you're getting this, you need to start by finding the positions. Mean that Q1 is going to be a quarter of n plus 1. We have 59 as our n, which is the total frequency. Mean that's going to be a quarter of 59 plus 1, which is 60. This is going to give us 15. Now, this 15 is just the position. Let's look at the position of Q2, a half of n plus 1, which means the position is going to be 30. And then let's look at Q3, 3/4 of 59 plus 1, which is 60. And that's going to be, is it 45? That's a 45, so position 45. Okay, so these positions can be obtained from the cumulative part. Okay, so 15, 30, and 45, okay? 15, 30, and 45. So 15, that's 12, 14, 15. We're gonna draw a line up until it meets our graph, and then drop that line down. So you can see that it is in between 95 and 100, but this would be a 97. Okay, so let me divide it by 2 or by 4, which is a 1,25. Okay, meaning that I'm gonna have a 98,75, something like that. So my Q1 is gonna be a 90, let me say 98, somewhere here. Remember, we are approximating. Then at position 30, follow the line of 30 up until it meets the graph, and then drop it down. Okay, this is 105. This should be 107, and we can take it to be 109. Okay, it's an approximation. And then we said 45, do the same thing. 42, 44, 45 is somewhere here, up until it meets the graph somewhere there. And then you drop it down. It should be slightly after 115. So you could give it as a 117. Q3 is 117. Okay, so we're done with those quartiles. So in most cases, we shall give you a range of values to say between this number and this number, we expect that to happen. All right, then how many rugby players' weights are in the top 25? So top 25, you're looking at what is happening after the Q3, because from Q3 to the maximum is a 25%. Okay, so from our graph, we say that Q3 was at 40 what? 45, and we had 59. So this is the top 25, if that is the Q3. So the top 25 is having how many learners? It's gonna be 59 minus 45. So 59 minus 45, that gives me 14 learners, okay? So we said 59 minus 45, that gives us 14 rugby players, not learners. So 14 players is what we needed. All right, guys, so that brings us to the end of this paper, okay? If there are any questions, please feel free to slot them in the comment section. I wish you guys all the best. Please go out there, make yourself proud, and believe in yourself that you can really make a difference. Thank you very much. Let's meet again. Bye-bye.